Hello friends, for BA B.SC students, book Algebra first, topic orthogonal and unitary matrix. Now we start from definition. Unitary matrix. A square matrix P over the field of complex number is said to be unitary if and only if p theta into p is equal to I. Here square matrix means number of row is equal to number of column. Field complex number is x plus eta y. Real plus x is real and y eta y is imaginary. P theta is equal to this one. Here p dash is equal to transpose of matrix and p bar is equal to conjugate of matrix. I is identity matrix. Note, if p unitary, then mod of p square is equal to 1 implies that p mod is equal to plus minus 1. Another definition of orthogonal matrix. A square matrix P over the field of reals is said to be orthogonal if and only if P transpose into P is equal to I. Square matrix is number of row is equal to number of column. Field of reals means real number if and only if denoted as this sign or simply if and only if. Article number 1. Prove that a real matrix is unitary if and only if it is orthogonal. Let A is a real matrix. A real matrix which does not have any imaginary element. So A theta is equal to A bar transpose is equal to A transpose. For this is 1. Now A is unitary if and only if, by definition of unitary matrix, A theta into A is equal to I. A theta is equal to A dash if and only if A dash into A is equal to I, so that A is orthogonal, hence proved. Now we go to exercise 2A. First sum, if P and Q are unitary, prove that QP is also unitary. Proof, we have P and Q are unitary by definition of unitary matrix. P theta into P is equal to I, Q theta into Q is equal to I. To prove QP is also unitary, so that we have to prove QP theta into QP is equal to I. Now we take QP theta into QP is equal to P theta Q theta Q into P. We combine Q theta into Q, and from 1 Q theta into Q is equal to I. We get P theta into P. From 1 P theta into P is equal to I, hence QP is a unitary matrix. Example 2. Show that the Police-Spain's matrix sigma x, sigma y, sigma z are all unitary. We take second part of this sum. We have sigma y is 0 eta minus eta 0. We know that if we prove unitary matrix, we need to find out sigma y theta. Sigma y theta is equal to sigma y transpose bar. We get 0 eta minus eta 0. Now we multiply sigma y into sigma y theta and we get 1001. Hence sigma y is unitary. Now sum 7 of this exercise. If P is unitary and Q is Hermitian, show that P inverse into Q into P is Hermitian. Proof, We have P is unitary. By definition of unitary matrix, P theta into P is equal to I. This is 1. And Q is Hermitian. By definition of Hermitian matrix, Q theta is equal to Q. We prove P inverse into Q into P theta is equal to P inverse Q into P. This is Hermitian. Now we take P inverse Q into P theta, P theta, Q theta, P inverse theta, P theta, Q theta, P theta inverse. If P is unitary, then P theta is equal to P inverse. We put the value P theta is equal to P inverse P theta, P inverse P inverse Q into P. Hence P inverse into Q into P is a Hermitian matrix. If you like this video, please subscribe, share and like my channel. Thank you.